Bismillahirrahmanirrahim. My name is Haider Ali Hamdani. I'm a physics OA levels teacher at Seeds School of Excellence, and today the topic of my discussion in A level syllabus is specific latent heat. Now you know actually about that. What happens is that whenever you're placing a piece of metal, sorry, a piece of ice on a surface, what happens is that it starts melting. And for example, if you're placing the same piece of ice in a beaker and you start heating it, what happens is that piece of ice starts absorbing heat, and the result of that it melts. So what happens is that piece of ice starts absorbing heat. So the amount of heat energy for which is required so that your ice changes its state of matter, okay? Or for example, you are trying to heat liquid or water, and amount of heat taken by water to convert it from liquid state to gaseous state, this is basically known as specific latent heat. If I want to generalize it, I'm going to say that the amount of heat required to change the state of matter at a constant temperature, that is basically known as specific latent heat. I would like to write this definition so that you guys can note down this definition. So the definition is it's the amount of heat energy required to change the state at a constant temperature. This is basically known as specific latent heat. ठीक है, तो I would like to generalize it keeping in mind the amount of mass. If I'm taking the amount of mass into account, this becomes specific latent heat. If I'm writing the definition like amount of heat energy required to change, so you could see here in the definition there is no specification of the mass. So this becomes your latent heat. If I want to generalize it in terms of mass, so I'm going to write the amount of heat energy required. You're going to add here, it's going to be per unit mass. So what I'm doing is that I'm trying to generalize it in terms of mass. So whenever I'm trying to generalize in terms of mass, the same latent heat becomes specific latent heat. So if I want to mathematically write it, what I'm going to write is, I would write that this is my specific latent heat, and that is equal to, as it is written, that it is amount of heat energy required. So it would be heat energy required per unit mass. This means you have to divide it by the mass. If I want to write it in symbolic form, your specific latent heat is denoted by small l. It's equal to amount of heat energy required. The amount of heat energy required is usually that's Q. You can also use, instead of Q, you can use E as well. That would generalize it more, and you have to divide it by mass. So what's going to happen is that if I generalize it and I want to find the amount of heat energy, so I can use the same equation for finding the amount of heat energy required. So the equation in that case turns out to be energy equals specific latent heat into mass. So you can use this equation as well, and you can use this equation as well. If you're using the above equation, you can get the value of specific latent heat. But if you're using this lower equation, what is the in that case you can calculate the amount of heat energy that is required. If you could see here, if you remember in my previous classes, I told you that you don't have to remember the units. If you remember the formula, you can easily remember its units. You could see here that that energy is usually measured in, you guys know that it's measured in joules. What about mass? Mass is measured in kilograms. The SI unit in which your specific latent heat is measured. So the SI unit turns out to be joules per kilogram, which can also be written as joules kilogram minus 1. Okay? So this is how you can calculate the amount of specific latent heat. Now, as I told you that you can convert ice into water as well, and you can change or convert water into water vapors or gaseous state as well. So this means I have two kinds of specific latent heat. What is that? In that case, if I'm changing from solid state to liquid state, okay, so in that case the temperature at which the conversion would take place, that would be a constant temperature. That temperature is basically known as the melting point. This means your specific latent heat would take place at a temperature which is known as melting point, and in this case the specific latent heat is basically known as specific latent heat of fusion. Fusion and melting are synonyms, so both means the same thing, that you are trying to convert a solid state into a liquid state. So this is something which is known as specific latent heat of fusion. And what is the symbol? In this case it becomes small l, and you place a small f, and I place a small f in the subscript. So this is basically the symbol of specific latent heat of fusion. Okay? Then on the same hand side, at the same time, if I want to convert a liquid state into a gaseous state, so this is basically known as vaporization. So what's going to happen? This case happens at a temperature which is basically known as boiling point, and this boiling point is a constant temperature. This does not change. Okay? This is the boiling point, and at the same hand, on the same hand side, the specific name for this kind of latent heat of fusion is known as specific latent heat of vaporization, and the particular symbol for this is small l with the small v in the subscript. So this is basically how you calculate the value of specific latent heat of fusion and specific latent heat of vaporization. And to add to it, you should remember that this formula actually calculates a value of specific latent heat that is basically underestimated, because you do not take the concept of amount of heat energy that is absorbed from the surroundings. Because if you're placing a piece of ice, you're placing it in the open air, so it's going to absorb heat energy from the surroundings. And in case if you're placing it in a beaker, the same would be applicable there as well. So in that case, you're not taking into account, when you're using this formula to calculate the value of specific latent heat, so what of fusion, so what you're going to do, you're not taking into account the amount of heat energy that is absorbed from the surroundings. So if you're not taking that into account, this means this amount of specific latent heat would be underestimated. The same thing as I discussed in case of specific heat capacity. I would try to conclude my lecture here, and we would try to continue our lecture in the same flow in our next class. Thank you.